So anyone need me to go over the definition of injective, surjective, and bijective? Any one of you need me to go over that? No? Okay, cool. So if not, let's try the first question. So this question was a quiz question. Let's try this. So we have function g from R to R, and it's defined by gx equals to 2x plus the absolute value of x. They want you to prove that G is a bijection. You cannot use calculus. Okay, so this is the first question. Give you a bit time to try this. You should be able to finish it within 10 minutes, okay? Yes, this is true. Whenever they ask you to prove something, it means it is true. We don't need to consider it's false. And I see one of you asked to prove if x times the absolute value of x is bijective. Yeah, we can do that later. We can do that later after this question. Well, if you know how to do this one, you should be able to do the one you asked. It's basically the same thing. This will be uploaded to YouTube. I don't know when because I'm not sure how long this is gonna be. Chapter, I think it's 4.4, 4.5, and 5.1 will be on your quiz. Let me check. Let me just double check because I'm not 100% sure. Where is it? Quiz 3 information. Yeah, 4.5, 4.4, 4.5, and 5.1 from course notes. So that includes those 3 topics. Okay. This is 4.4, this is 4.5, and this is 5.1. Anyway, anyone finish this question? Yeah, it's pretty reasonable. Only 3 subsessions. Anyone finish this question? You could. Yeah, you can divide into cases. Yep. Can we write absolute value of x as square root of x squared? You could, but I don't know why would you do that. I do not recommend you to do that because that's gonna make your life even harder. You wanna simplify this, so you wanna get rid of the absolute value, but you wanna make it easier instead of harder. What you are doing is you are making it more complicated. So I do not suggest you to do that. So for people who are getting stuck, I'll give you a hint. Recall the definition. Let me write it here. Recall if you have y equals to the absolute value of x, you can write it as a piecewise function where this is x if x is greater than or equal to 0, and this equals to negative x if x is less than 0. Okay, that's gonna make your life easier. So try to use this in this question. Okay, so what I'm doing is that I'm writing this whole function as a piecewise function so that when x is greater than or equal to 0, we have 3x. How did I get 3x? Because this will give us x, so 2x plus x is 3x. And when x is less than 0, you can get negative x. 2x plus negative x will give you x. So my first step is that I'm gonna write it as a piecewise function so that I don't have to deal with the absolute value. Okay, so that's where our 2 different cases come from. Our first case is when x is greater than or equal to 0, and the second case is when x is less than 0. So let's prove it's it's injective first. How's that? Okay, so for injectivity, let's let x1, x2 be in real number. Where is the typo? No, it's x. What you have is x. Your x is -2, so g of x is -2, which is x. There is no typo, okay? And let x1, x2 be in real number, and let's suppose g of x1 equals to g of x2. Okay, so that's my first step. What I want to show is that I want to show x1 equals to x2. So here's the question, what do we do next? What do we do next? Could you do it the other way when x1 does not equal to x2? Yes, we can do that later. Well, we need to do cases, okay? Because this depends on whether your x1 and x2 are greater than 0 or less than 0. So if you substitute it back, which one are you going to choose? Okay, so which g of x are you going to choose? So we need to discuss cases. So the first case is one, let's say when x1 and x2 have different signs. If x1 and x2 have different signs, then our g of x1 can never be g of x2. So this is not our case. This is not being considered. So contradiction. Okay, the second case is when both x1 and x2 are non-negative. Then we have 3x1 equals to 3x2, which will give us x1 equals to x2. Okay? And the third case is when both x1 and x2 are negative. Then you have x1 equals to x2 directly. Okay? Therefore, G is injective. Any question? How did we get 3x and x? Okay, here. Because we know that the absolute value of x equals to x if x is greater than or equal to 0. So when x is greater than or equal to 0, this whole thing becomes x. And 2x plus x equals to 3x. Okay? Here, when x is less than 0, the absolute value of x becomes negative x. So 2x minus x will give you x. Any other question? So this is for injectivity. Let's prove surjectivity. No more question, right? surjectivity. What we want to do is, I'm gonna first let y be in our codomain. What I want to do is I want to show, this means want to show. So I want to show that there exists x in real number, this real number. So this real is a codomain, and this real is a domain. Oops. So I want to show that there exists x in your domain, which is R here, such that f of x equals to y. So this is what you need to prove. Okay, this is what you need to prove. I see some of you are answering each other's questions, so I'm gonna prove this and I'll go back to see if there's any question left that's unanswered. Okay, so this is what we want to show, and what I'm gonna do is that I picked my y in R, and I'm gonna discuss cases as well. Okay, let's see. Someone said you're confused about the first case. Okay, let's go back to the first case. This case, I'm just saying that when you pick x1 and x2 in real number, they can be both positive, they can be both negative, they can be both zero. We don't know about that because you picked arbitrary x1 and x2. Okay? Now we have different cases because you could have one positive, one negative, or you could have both positive, you could have both negative. My first case is that when we have one positive, one negative, so they have different signs. When they have different signs, your g of x will get your let's say this is positive, this is negative, okay? Then your g of x, 1 and x2, will give you one is 3x, the other one is x, but that's gonna have one positive and one negative as well. So that means that our g of x1 and g of x2 can never be equal. So we don't have this case. We only have when they are both positive or both negative. Does that make sense? Okay, seems like you guys are good. So let's do surjectivity. For surjectivity, you need to discuss cases as well. Okay, why is that? Because you picked y in real number. Whatever your y is depends on if your x is greater than or equal to 0 or less than or equal to 0. So you have this case and this case. Now we only know information about y, we don't know x. So your case is going to be, the first one is when y is greater than or equal to 0, and the second one is when y is less than 0. Okay? So my first case is that if y is greater than or equal to 0, okay, y is greater than or equal to 0, you'll get 3x equals to y. So we can pick, let my x equals to y over 3. Then, oh, by the way, since y is real number, this is real number as well. Then we have g of x, which equals to g of y over 3. That's gonna give you, since here your x is positive because y is positive, okay? This will give you 3 times y over 3, which is y. And the second case, if y is less than 0, I'm gonna let x equals to y. Again, this is real number as well, since y is a real number. Then g of x equals to g of y, which will give you back y. How did I get through? How did I get this? I'll tell you how did I get all of those, okay? But here is my proof. I'll tell you why. I'll write my rough work here. So basically, we have this. I'm gonna copy paste this below so that I don't have to go up and down, up and down. This is our function. We picked a y in real number, and I'm letting y be greater than or equal to 0. So we know that when y is greater than or equal to 0, we have y equals to 3x. Do you agree with that? Okay, so when y is greater than or equal to 0, we know that y equals to 3x. So you isolate x, so x would give you y over 3. That's how I got this y over 3 for here. And then how did I get this? Because y over 3 is positive. Positive, so that's when you have this case. Okay, this is positive, which means your y equals to 3x. You plug it back in, which will give you back y. So basically, for surjectivity, what you need to do is you need to find, okay, you need to find an x in your codomain such that your f of x equals to y. So your x should be an expression of y because you know y is in real number or y is in your codomain. So basically you need to find x in an expression of y such that when you plug it into f of x, you'll get back to y. If you show that you found that, then you prove that it's surjective. Okay, any question? And same idea for this case, okay? Wait, it's G. And since it's surjective and injective, we know it's bijective. Okay. Yeah, sure. Let me write it in another color. So for surjectivity, what you need to do is you wanna show for all y in your codomain, there exists x in your domain such that f of x equals to y. This is what you need to prove for surjectivity. Okay, so you pick y in your codomain and you wanna express your x as an expression of y, and when you sub in your x into your function, you get back to y. If you can find such x in your domain, then you prove that the function is surjective. Any other question? Any other question? Because, okay, how did I get this? Because when y is greater than or equal to 0, we know that, okay, when y is greater than or equal to 0, we know that y equals to 3x. And I want to isolate x so that I write x as an expression of y. So this will give you x equals to y over 3. Okay? Let's try another example. Those are all induction questions. Interesting. Use a bijection. Just give me a bit time to find another example. Feel like we can do this one. Just give me a sec. We can do last winter's quiz, because last winter is really similar to this semester. So let's try last winter's quiz. No, last winter was not hard. We'll do one of that too. We'll do one of 2 variable one as well, okay? Wait, they didn't test people on a proof. This is interesting. Last winter they didn't test on proof. It's all induction. Okay. Me try to find another term now. What about summer? Let's try summer terms. 2020 summer. Quiz. Might be quiz 4. Let me see. This is induction as well. They test people in induction a lot for some reason. Exam average, it depends. It really depends on the term. Sometimes it's pretty high, sometimes it's pretty low. Usually, I would say usually if the average before exam is pretty high, then exam average is pretty low. And when the average for before the exam is low, the exam average is pretty high, generally speaking. I did this one in my tutorial already. Okay, so let's get more. 2018 fall. 2019, 20. Oh, you are doing badly doesn't mean everyone else are doing badly. I mean average as like the average of the class, not average of a specific people, okay? Let me try this one. Oh, this one is so similar to the one we just did. Yeah, it's basically the same thing. I don't know why they test people on almost identical thing. Okay. It's usually 40%. I'm not sure about this term because for this term, I think the syllabus looks slightly different. So I am not sure about this term. No, not the average, the exam worth for 40%. Not the average. Okay, let's try this one. Two. Prove that. Oh, let's see. This one I'm gonna ask you. So we have a function f from R to R, and the function is defined as x when x is less than or equal to 0, and 1 over x when x is greater than 0. So what do I want to do? I want you to determine if it's if f is injective, surjective, bijective, or neither. Okay, and then I want you to justify your answer with a proof or counterexample. Okay. Could have a counterexample, yes. This one could have counterexample. I feel like I'll tell you what I think. I think one of your answer question could be something like this. So they might give you two functions. So the question will be like, oh, determine if the following function is injective, surjective, bijective, or neither. Justify your answer with a proof or a counterexample. And you might have two parts. They might give you something like one, they give you a function, and then two, they give you another function. It's just a guess. If you think it's injective, you don't need to prove it. If you think it's not injective, then you gave a counterexample. Yeah, basically you can graph it in your head. But graph is not a proof, okay? Graph is not a proof. Oh, I forgot to talk about marking scheme. We'll talk about that later. So, do you guys think is it injective, surjective, bijective, or neither? Bijective. Okay, it is bijective. So, it is bijective. So that means you need to prove it's injective and surjective. It's pretty similar to what we did before, but let's just see if you guys can do it yourself. Anyone want to write the proof yourself? I think you can. I think you can write. You can annotate. Yeah, I believe you guys can annotate. You can try to write it. You can try to write it here, and let's see if any one of you can get it. Okay, it's okay. You can type as well if you want. Let's say let's one of you write try to prove injectivity here. And the other one of you try to prove surjectivity here. Okay? Let's see if any one of you is brave enough to do it. It's okay, even if your writing is extremely messy, that's okay as well. We'll figure it out. It's good to watch you guys doing it because I can tell you the common mistake you make. Well, if you make a mistake here, you'll never make the same mistake on your quiz or test, right? So and also you can add to what other people are writing, or if you think their answer is wrong, you can correct them. And later I'll give you a marking scheme, and let's see what you guys can get. Are we done? Anyone else want to add anything to it? Okay, seems like you guys finished the proof. Let's have a look. So let's look at the injectivity first. Let x1 and x2 be in reals, okay? Suppose that f of x1 equals to f of x2. When both x1 and x2 are positive, so when both are positive, we have this. Oh my god. When both are positive, we have 1 over x. So that's we have 1 over x1 equals to 1 over x2. That's gonna give you x1 equals to x2, okay? When both x1 and x2 are negative, so when they are negative, we have x. That's gonna give you x1 equals to x2 directly. So it's injective. Well, someone added here if signs are different than contradiction. Yeah, it looks good. Let me see if there's anything I wanna add. Well, for signs are different, you need to explain why we have a contradiction. Okay? And someone said can also do this. Yeah, that works too. Our injective proof always like this. They are really similar. So you either use this or you do x1 is not equals to x2. So you either do this or you do or you do this. But what we are doing here, this one is more commonly used. Ah, okay. So let me. Anyone want to explain why when signs are different we have contradiction? Yes, they can never be equal. Okay, because if the signs are different, then whatever your f of x1 and f of x2 you get, they're gonna have different signs as well. Does that make sense? Because if x is less than 0, then f of x is less than 0 as well. If x is greater than 0, then 1 of x is greater than 0 as well. So whatever your f of x is, it has the same sign with your x. If your x1 and x2 have different signs, then f of x1 and f of x2 have different signs as well. So they can never be equal. That's a contradiction. Because you're assuming that f of x1 equals to f of x2. Let's say x equals to mod 3. Don't use modular arithmetic here because it's not covered in 102 yet. Okay? Do you mind teaching how to write a formal definition of that? What do you mean formal definition of that? Oh, you mean how to write the contradiction formally. Oh, okay. So you can write this. I'm gonna erase this part so that I can write something and people can still see this. Okay. Let me see if I can erase this. Okay, I can erase this part. I'm gonna. Oh, oops. Didn't want to erase that. Okay, let me erase this. So, if we have, we go a bit lower. If x1 and x2 have different signs, then f of x1 and f of x2 have different signs as well. Okay, here you wanna explain. I'm gonna write here, explain why they have different sign. Since let me see. Since when x is less than or equal to 0, f of x equals to x, which is less than or equal to 0 as well. And when x is greater than 0, f of x equals to 1 over x, which is greater than 0 as well. So, okay, so this is why they have different signs. So this contradict, I have no space to write it, but this contradict with the assumption that f of x equals to f of x1 equals to f of x2. Okay. Are surjection proofs also always similar? Most of the time they are similar, but sometimes you have like weird function. So when you have like a really weird function, sometimes isolating x might not be possible. And that's when you need to look for other different kind of proof. Okay, let's look at surjectivity. So let y be in real. Oh my, the y be in real number. We want to show that there exists x in real number such that f of x equals to y exactly. Okay, the first part is perfect. Now we discuss cases when y is greater than 0. Let x be 1 over y. So y is greater than 0. That means we have this, okay? Let x be 1 over y, which is also real number. Since y is a real number, yes. Then g of x, I mean f of x. Then f of x, here should be f of x, okay? Then f of x equals to f of 1 over y, which is 1 over 1 over y, which will give you y as needed exactly. When y is less than or equal to 0, let x equals to y. Since y is in real, x is in real as well. So f of x equals to f of y, which will give you y as needed. Therefore, g is surjective. Yeah, perfect. This is perfect proof. Okay, so all of you got a perfect proof together. I suppose if you are giving a group quiz, you might get perfect. But yeah, is there a question where domain codomain belong to different sets? We'll talk about that. Let me see if there are any unanswered questions. You hope the quiz is like this? This was a quiz question. The two questions we did, they were both quiz questions, okay? Yeah, so it's actually easier than you thought. But for both questions, people did not do well on those questions. When they see absolute value symbol, they freak out. It's pretty sad when people can't solve absolute value. I'm gonna clear everything here. Clear all drawing. Okay? And let's try another example. When you have different different domain and codomain, and when you have two variables. Just give me a moment. Let me find a good question. Which one do I want to do? Let's do this one. So we have another function. F map from, you want different. Let's see, F map from natural number, Cartesian product, integer to rational number. Okay, and your f of nz equals to n to the power of z. Question is, determine if it's injective, surjective, bijective, and prove or give a counterexample to justify your answer. So first of all, is it injective? Is it surjective? Is it bijective? Or is it neither? And if you think it's not injective, you need to give a counterexample. If you think it's injective, you need to prove it. This one is pretty simple, so I'll give you another one. Let me find another one. Again, if you have an answer, you can write it on the board and we can discuss together. Okay. I'll give you more space to write. Well, I think all of you have some thoughts, so you can put it on the board. If you think it's injective, then you need to prove it. If you think it's not surjective, I think they all think it's not surjective, then you need to give me a counterexample. Okay. Write it here. Write all your counterexample down. Not in the chat, on the right, on the whiteboard, okay? Oh, also I have a video about injective, surjective, bijective. I will post the link here so that you can watch it later. I will post the link. Yeah. Then write down another one. This one, we are not gonna do it. Do we wanna do it? Because I wanna move to strong induction. This one is your homework, okay? If you have any question, email me after. If you can't solve it, you can email me. You can ping me in the Discord channel or whatever you feel comfortable. So we have F. Okay, this one is a good one because we talked about absolute value. We never talk about square root. Okay, so when you see this, what do you do? So think about that. If you have any question, email me. But we are not gonna do this today because I wanna move on to strong induction. Okay, seems like you guys are done. Let's see. It's not injective and it's not surjective. That's correct. So we add correct. This is correct. This is correct as well. Take n equals to 3, z equals to 0. Then n to the power of z is 3 to the power of 0 equals to 1. And 7 to the power of 0 is also 1. So thus there are more than a single x. This is wrong, okay? More than a single x. What is your x? Fix this. This is wrong. Let me clear this, and whoever wrote this, please fix your answer. More than what? That maps to a given y value. Okay, that's cool. More than what? More than something mapped to a given y value. Not surjective. there does not exist n z in cos z such that f of x equals to -1. So why is that? F of x equals to -1. I'm not sure if you can get full mark just saying that it cannot be -1. You need to justify it a little bit more, I think. Yeah, I think you need to justify a little bit more. Why can you never map to -1? Okay, but this is not surjective. You guys are right. Let's see. Would the counterexample of 5/3 also work for not surjective? Actually, I can't even see the 5/3. Yeah, this one, it's hard to justify why you can never map to that. So let's say n to the z equals to 5/3. Yeah, I think it works. It works. Yeah, I think it's hard to justify, so probably if you leave it like this, it's okay. Any negative y number is enough for. Yeah, that works too, because you can never map to a negative number since you have natural to the power of something. Yeah, that works too. So as long as you can find a counterexample, it's okay. Question 4, we're not gonna do it because I want to move on to straw induction. So let me clear everything first. Oh, there's one question that I want you to make sure you know how to do it. It's a textbook question. I covered it in the video I sent it to you, so hopefully you watch that. Yeah, it's a question with two variables. So it's this one. Right here. I covered in the other video, so I'm not gonna do it again. But make sure you know how to do something like this. Okay? Make sure you know how to do something like this. Didn't I send you the video already? Oh, someone send the video again. Yes, thank you. Okay. Yes, make sure you know how to do something like this. For this question, you can argue that your n is a natural number. So whatever your z is, you can never map to negative numbers. Okay?